Figure 4.3 shows the conductor configuration of a completely transposed three-phase overhead transmission line with bundled phase conductors. All conductors have a radius of 0.74 centimeters with a 30 cm bundle spacing. A determine the inductance per phase in mH, km and in mH. B find the inductive line reactance per phase in omega, me at 60 Hz. Convert the units into one common unit. In this problem, meters is my preferred unit of measurement. Feel free to use your preferred unit of measurement. Calculating the inductance of a transmission line, engineers must account for magnetic fields existing both outside and inside the wire. To avoid tedious calculus, we use the geometric mean radius, or GMR. It replaces a solid wire with a fictitious, hollow shell that has zero internal magnetic fields, but still yields the exact same total inductance. To make this trick work for a single conductor, we use the constant 0.7788 derived from the physics of internal magnetic flux. When a phase consists of a composite conductor made up of multiple strands, this logic scales up. The total GMR is calculated by taking the n squared root of the product of all n squared distances between the individual subconductors, where the distance of a subconductor to itself is replaced by its own shrunk radius, r. In power system analysis, geometric mean distance, or GMD, measures the effective spatial distance between the different phases of a transmission line. GMD mathematically blends all of these varying distances into a single, uniform equivalent value. When phases are made up of bundled cables containing multiple strands, we calculate the GMD between two phases by measuring the distance from every single strand in the first phase to every single strand in the second phase. We then multiply all of those distances together and take the corresponding mathematical root base, which is vital for predicting voltage drops and balancing the electrical grid. calculated the individual GMDs between each specific pair of phases. You simply multiply those three values together and take the cube root of the product. To calculate the electrical inductance of a transmission line, engineers rely on the physical layout of the system by combining two mathematically simplified values, geometric mean distance and geometric mean radius. The total line inductance is calculated by dividing the uniform equivalent distance by the effective radius, taking the natural logarithm of that specific ratio, and multiplying the result by a standard physical constant. Convert the answer to the problem's required units. To calculate the inductive reactance, you simply multiply the line's inductance by the angular velocity of the electrical system. This angular velocity is defined as the product of 2 pi and the system's operating frequency. Convert the answer to the problem's required units. Thank you for watching. Like and follow for more.